Hello, everyone. Hopefully, you are keeping up with the homework. Okay, so we are doing 7.4 here. We're going to focus. We're going to focus a little more on multiplying and dividing radicals here. Okay, so take notes. 7.4 multiplying and dividing radicals. Okay, so let's just kind of recall the product rule. So just remember with the product rule, you could multiply them or you can split them up, right? So if you have this, right, you can split it up or you can write it, you can actually multiply them and treat it as a single one. Okay, so let's go ahead and look at these examples where we have to multiply and simplify. Okay, so let's start with this first one. Square root 5 times square root 10. So like I said in the last section, uh, you can either separate them, split them up, or actually multiply them. So you have to see what would be beneficial. So here, they're split up. I can't simplify that. I can't simplify that. So if you can't simplify them when they're split, then try multiplying them together. And I get 50. And not that 50 is a perfect square, but I can actually split this up differently, right? I can split this up using 25 and 2, in which case it allows me to simplify, right? Okay, so that's what we're going to be doing here. So let's take a look at this next one. Suppose I have 3 square root 6 times 2 square root 3. Okay, so I can't simplify this one. I can't simplify this one. But if I multiply them 3 times 2, I can only do the outside numbers. And I can do the inside numbers. 6 times 3 is 18. Okay, 18 is not a perfect square, but I can split it up differently. I can split it up using 9 times 2. Okay, and square root 9 is 3, and square root 2 will stay. So here I get 18 outside and square root 2. Okay, and let's take a look at this third example here. Suppose I have negative 2 cube root 7x times 6 cube root 49x squared. Okay, so that's not a perfect cube. Those are not perfect cubes. Okay, so let's go ahead and multiply these together. So outside I get negative 2 times 6, so that's negative 12. And then inside 7 times 49 is 343. 343 and x cubed. Okay, so 343 is a perfect cube. Okay, that's 7. So here, negative 12. And cube root of 343 is actually 7. And cube root of x cubed is x. Okay, so here I actually get negative 84x for my final answer. No radicals left in this one. Okay, because cube root of 343 is actually 7. Okay, let's take a look at multiplying like a single radical with a binomial. Okay. So more multiplying and simplifying. Okay, so let's take a look at this first example here. Suppose I have 3 square root 3, and I want to use the distributive property to 4 square root 8 minus 5 square root 10. Okay, so what you end up doing here is you do the distributive property. So, and again, you can multiply the outside numbers and then multiply the inside numbers. So this is going to be 3 times 4 is 12. And then inside 3 times 8 is 24. And then I'll do the same thing here. 3 times 5 is 15. And then inside 3 times 10 is 30. Okay. And then from here, then you want to go ahead and see if you can simplify these radicals. So here, 24, I can split that up. I can split that up using perfect square 4 times 6. And then over here, can we split that one up? I don't think so. 2 and 15, 3 and 10, 5 and 6. None of those are perfect squares. So we'll keep that. So then here, I get 12 times 2 times square root 6 and 15 times square root 30. So I get 24 square root 6 minus 15 square root 30. Okay. And let's take a look at this next one. Suppose I want to do a binomial with another binomial. Okay, so you do have to distribute the square root 7 to both of them. Okay, so let's do that. Let's distribute it. Let's do the distributive property with square root 7. So square root 7 times here, square root 7 times there. Okay, so I get square root 49 minus 9 times square root 14, right? It's 7 times 2. All right, once you're done doing the distributive property with square root 7, now you're going to do the distributive property with the square root 2. You're going to do square root 2 times this, square root 2 times that. So I get square root 14, and then I get minus 9 square root 4. Okay, so you get 4 terms here. Let's simplify what we can. Square root of 49 is 7. This one, 14, I can't split that up. And here, this is negative 9 times square root of 4 is 2. Okay, so this is going to be negative 18. So negative 18 plus 7 is negative 11. Okay, and then here, these two are like terms. There's a 1 out here. So negative 9 plus 1 is negative 8. Okay. So that's the answer there. Okay, let's take a look at this next example. Suppose that I have this. Okay, so this means repeated multiplication, right? And that would give me square root of 25. And that gives me 5. Okay, so that's kind of pretty straightforward, pretty intuitive. Okay, let's take a look at this one. Suppose that I have 2, and I have cube root 7x squared, and this is raised to the third power. Okay, so here, so right here, because I have this cube root and this cube, yes, they will cancel. But then don't forget to do 2 to the third power, because everything in here gets raised to the third power. So it's 2 to the third power times this thing to the third power. So the cube root and the power 3 will cancel. You'll have that, okay? And then work this out. That's 8 times 7x squared, and that is 56x squared. Okay? And let's take a look at this one. Suppose I have this, 8 minus square root 3 squared. Okay, so you can use your shortcuts from multiplying binomials. Here, let's just kind of recall down below here. When you had something like this, 2x minus 5 quantity squared, right? To do this quickly, you square, double their product, and then square. You're going to end up with a trinomial, 3 terms, right? So you're going to square this. It's going to be minus, since this is minus. And then you take their product and double it. So that's 10x, double it, 20x, and then you square the 5. Okay, so you can use that same method up here. Okay, so it's going to be a trinomial. You're going to square that, so 64. And then you're going to take their product and double it. So that's going to be 8 square root 3, but then double it. So you're going to have 16 square root 3. And then you're going to square this. When you square this, you end up losing the square root. So you end up with just 3. Okay. And then combine like terms, we get 67 minus 16 square root 3. Okay. Okay, so make sure right here, when you square a square root, they cancel. Okay, let's take a look at rationalizing denominators again, but we're going to extend it to having more than a single term in the denominator. Okay, so let's take another look. Okay. All right, so we already know how to deal with something like this, right? Square root 5 over square root 3, right? We know this doesn't simplify, right? They don't simplify if I do a single radical or if I have them split. And so, but I can't have a radical in the denominator. Okay, so then what I end up having to do is rationalize the denominator. So I have to multiply by square root 3 over itself. That way I get square root 9, right? So I get square root 15 over square root 9. And that square root 9 is a nice perfect square, and we get 3. Now don't cancel these here. These do not cancel because this is not under a radical. This one is under a radical. Okay, so you can't simplify them. Okay, this would be the final answer. Okay, so if we have something like this, square root 20 over 7. Again, even if I split them up, I can't get rid of that radical in the denominator, right? Sure, I can simplify the square root 20, right? Breaking it up as 4 and 5, 4 times 5. But I still have that radical in the denominator. And we said that when you're simplified, you don't have any radicals. Okay, so we're going to have to take this and rationalize the denominator. So I'm going to multiply by square root 7. That way I get square root 49, which is a nice perfect square. All right, so here I get 140. And here I get square root 49. And that's just 7. Okay. 140, well, we already saw here that 20 is divisible by 4. So I could break it up, which means I could still break this up using 4. So when I split that up, it'll be 4 times 35. Okay. So that's going to be 2 square root 35 over 7. And I don't have any radicals in the denominator, okay, because I rationalized the denominator here. Okay. All right, so we are going to take a look at what happens when we have more than a single term with a radical in the denominator. Okay, rationalizing denominator with binomial. Okay, so let's take a look. So if I have this, if I just had that, then I would just rationalize this by multiplying by square root 2 over square root 2, right? Okay, but what if I have this, a binomial in the denominator? Okay, so the way you rationalize this here is you multiply uh, numerator and the denominator and denominator by what we call the conjugate, by the conjugate of the denominator. So what's the conjugate? So here, let me just do quick little examples here. Conjugates. So if you have a plus b, the conjugate would be a minus b. Okay? All right, so let's take this problem. 1 square root 2 plus 1. Okay, so if I need to multiply by the conjugate, then that means I have to multiply by square root 2 minus 1. Okay? That's the conjugate of the denominator. And the reason why is because, here, put a little, when you have a plus b times its conjugate, a plus b times a minus b, you always end up with a squared minus b squared, right? And so that's why we multiply by the conjugate, because if we end up with a squared minus b squared, then we end up squaring away our radicals, right? And we're trying to get rid of our radicals in the denominator. Okay, so in the numerator, I just get this. And in the denominator, I'm going to go ahead and follow this rule. So here, I'm going to get square root 4 minus 1. But what's the square root of 4? 2. And what's 2 minus 1? 1. And there I get rid of my radical in the denominator, which was this. So this is just another way to write this problem. Square root 2 minus 1. Okay? All right, try this one. Okay, rationalize the denominator. And suppose that you have this for the numerator, and suppose you have this for the denominator. Okay, so go ahead and figure out what you need to multiply by. Remember, you have to use the conjugate. Okay, hit the pause button and then come right back. Okay, so here I'm going to go ahead and multiply by the conjugate of the denominator. So I'm going to have to multiply by square root x plus square root 2. Okay, and I could use the shortcut for both of these. So here, this is just x plus 2, square root x plus square root 2, quantity squared, right? So for the numerator, you should have gotten x plus 2 times 2x plus 2. And then for your denominator, you should have gotten x minus 2. Okay. Are you wondering how I got those answers? Okay, here, let me multiply it out. So you just have to do the distributive property. If you understood that, that's the end of the notes. If you want to see me explain how I got these terms, then stick around. Okay, the way I got those terms, so I do the distributive property. This times this is square root x squared. Square root x times this is square root 2x. Now I'm going to use the distributive property with this one. Square root 2 times square root x is square root 2x. And square root 2 times square root 2 is square root 4. Okay. And then over here, same thing. Square root x times square root x is square root x squared. Square root x times 2, square root 2 is square root 2x. Now distribute this one. Negative square root 2 times that is negative square root 2x. Negative square root 2 times that is negative square root 4. Okay? And then simplify everything. Here, square and square root cancel, so I have x. Here, these are like terms. 1 plus 1 is 2. So I have 2 square root 2x's. And then here, square root of 4 is 2. And then here, square and square root cancel. Here, 1 minus 1 is 0. And then here, square root of 4 is 2. Okay, so that's how I get those terms up there. Okay, so that is it. Again, if you have any questions, make sure you text me or email me.